Okay, so these are going to be our video notes here for Unit 3A. Again, make sure you have your timeline out so you're following along accordingly. The main concepts we're covering this unit are going to be dealing with segments and angles. So, collinear, big idea here, is something that looks like this. So here we have A between B and C. So, AB represents the distance of AB. And let's see here. Oh, my bad. AB represents the segment of AB and the distance between points A and B. Postulates or axiom are rules that are accepted as true. A theorem is a rule that must be always true. Okay, the idea here. If B is between A and C, so if we have this picture, this one here, then AB plus BC is equal to AC. Think of it, the two small parts added together make the whole thing. Alright, so we're going to go ahead and do this all together. Michael Schofield is driving on Route 40 from Little Rock, Nashville to find his true love, Sarah. He stops in Memphis for lunch. The distance from Little Rock to Memphis, okay, so let's look at our map here. Okay, here's Little Rock. So from Little Rock to Memphis is 139 miles. The distance from Little Rock to Nashville, so our whole thing here, is 350. How far does he travel after lunch? So we're trying to figure out this distance here of x. So two small parts added together equal the whole. Subtract. Looks like that distance from Memphis to Nashville is about 220 miles. Alright, now let's crank it up a notch and bring some algebra in here. Okay, so we're told point J is between H and K. So what that means is that here's some point H, here's some point K. If J is between, that means J is in the middle. So our theorem here would be HJ plus JK equals the whole of HK. So we're going to use that to solve problems 2 and 3. Okay, HJ is 2x plus 5, so I have 2x plus 5 plus JK, that's 3x minus 7. And it's saying KH or HK. They mean the same thing. It doesn't matter. As long as you have the same two letters, order does not matter. Is equal to 18. So let's combine over here. And solve. Now, be careful, because here we found x, but we're not done yet. It also wants the value of hj and jk. So for hj, this is 2x plus 5, and jk, oh, there we go, is 3x minus 7. So to find their lengths, I'm going to go ahead and plug in that 4 for my x into each one. So this one's going to give us 13, and this one 5. So again, make sure you're answering all parts of the question. Here, same concept, we're just plugging in, so we have hj, 10x plus 8, jk is 20, and hk, 12x plus 4. So this would give me 10x plus 28. Moving our variable to the left like we've done in the past. You get x is equal to 12. So it says find the value of x and the length of the entire segment. Well, the whole segment, that's hk. So hk, 12x plus 4. So that's 12 times 12 plus 4. So that gives us 148 for h. Okay. Always make sure you nice and clearly identify or circle those answers for me. Alright, moving on here. So, let's label what we know. Fk is 24. So this whole thing here, Fg is 6, Hk 14, and we want to find GH here. So that GH is what we're trying to find. So let's think, if I add up all three of these small parts, it's equal to my total here, 24. Let's combine. Subtract. X would be 4 here. Our GH is 4. Alright. Aaron Harrison stopped by Grader's to get a double scoop on his way to Louisville for the big game. The cone is 5 inches tall. The first scoop is 25.5 minus 3x inches tall, followed by the final scoop, which is 2x minus 13 inches tall. The whole cone stands 10 inches tall. Alright, let's set up this equation. So here's a nice cone. So let's think about the height of this thing. So, the whole thing is 10. In our two small parts here, and here. So, if we add those together, we should get 10. So let's think. We have 25.5 minus 3x plus 2x minus 13. And it's equal to 10. So, solving. Let's combine these. It gives me negative 1x. Combining my numbers. Positive 12.5. Subtracting. And dividing. So x, what we're looking for there, the height of the top scoop in inches, is 2.5. Alright, part B, so that was our A here. So go ahead and take a minute now and get that down. Part B here, we're actually going to skip over. So, at this point, you are good to move on. Real quick catch here, something we missed. That cone's 5 inches tall. So, let's redo problem 1 real quick here. So what that means is I should add on plus 5 from my cone and set it equal to 10. So, solving again real quick here. We'd get negative 1x plus 17.5 is equal to 10. And then subtracting. Dividing. So our x should actually be positive 7.5. So, my apologies there, quick correction. Don't make the mistake your own. Everyone makes them though. So again, take your time. Don't try and rush. Alright, what you're working on now is number 2. So kind of given a lot of diagrams here. We're working through, and if you're correct, the answer should make sense at the end. From there, we are going to move on to number 3 for another section of notes. So 3 here is going to be our first kind of introduction with angles. So an angle is formed by 2 rays. These are rays here, so they have a definitive end and they go on forever in some direction, with a common endpoint. This common endpoint is known as the vertex. The rays are called the sides name an angle using 3 letters. So we're going to use 3. So this could be angle ABC or CBA. So again, the vertex is always that middle letter. Moving down. So types of angles, if it's small looking, this would be what's known as an acute angle. Bigger looking, so bigger than that 90 would be obtuse. And exactly 90, so if we got that, that's a right angle. We won't trick you if it looks like a right angle unless we tell you it's not. It's a right angle, but you'll usually have that box there. If it looks bigger than a right angle, it's obtuse, and smaller than a right angle, it's acute. So, the vertex here, this angle would be K, so we're looking at this angle. The sides would be JK and LK. And again, you could put those letters in either order. A couple of ways to name this. Let's just focus on 2. So we could do JKL or LKJ. Notice the vertex is in the middle. This angle looks bigger than love you, B. Okay, sorry about that. As you guys will notice in a lot of these notes, my daughter really dislikes when I do work at home, so she tries to chime in as much as possible. Okay, so classifying the angle, this looks definitely bigger than 90, so this one's going to be obtuse. Alright, moving on to example 2. Name the vertex of angle 2. Angle 2 is here, so the vertex would be that point, T. And the sides of angle 4, well, that's looking here. So the sides of this angle would be WT and ZT. Another name for angle 3, well, that's here, so I need my sides, and my vertex is still T, so let's go UTZ. Another name for 1, well, that's these ones, so let's go with XTY. The sides of angle 5, well, here's angle 5, it's a right angle, and the sides would be WT and YT. Classify YTW? YTW. Well, it's got a box, so it's a right angle. YTU. YTU. Notice I'm following that order. Well, it looks bigger than 90, so that's obtuse. XTU. XTU. Definitely smaller than 90, so it's acute. And WTU. WTU, well, that's definitely bigger than 90 on both sides, so it's looking obtuse. Okay, couple different facts about angles here that we can use. So these are going to get in those more complex problems. Vertical angles. An example of this. So, our vertical angles here would be either here and here. In that case, I would have angle ABC in vertical, so when I get in like that X, that cross pattern, they're always going to be equal. So ABC would be the same as XBY. Or going side to side, ABX, so angle, would be congruent to or equal to CBY. So the key idea of vertical angles, they're always going to be equal. Let's think about adjacent angles. So adjacent angles here would be this angle and this angle, meaning they're next to each other. So here, if I looked at this first one, ABC, angle ABC, and added it to the angle CBX, it'd be equal to the big angle that they form together. So that'd be angle ABX. That one's similar to our segment addition we learned earlier. a linear pair. Key idea here is we got a straight line. So let's throw some points on here. So in this linear pair, if I consider these two angles, I could say that angle ABC plus angle CBX, anytime you have two angles and they're on a straight line, they're always equal to 180. Complementary, those refer to angles that sum to 90. So here, if I consider these two angles, I would have angle ABC plus angle CBX, and I could say that these two are equal to 90. Supplementary angles are the exact same thing as a linear pair. So here, we're just going to look at that linear pair. So just know that linear pair and supplementary angles mean the same thing. From here, we're going to do a little bit more notes on number 4. So here, we're going to work on numbers 1, 2, and 3 together. Okay, so first, we're given EF bisects DEG. And it says it's not drawn to scale. So bisects means, since EF bisects this angle, that means that this part and this part are congruent. They're the same. So we know from that bisects that angle DEF is equal to or congruent to angle FEG. So let's see here. DEG is 88. Find FEG. Okay, well, let's think. If these are the same, let's call them both X. You're going to want to draw this picture for each problem we do. Right now we're working on one. I'm going to erase each time. So, I know my whole thing here is 88. Let's think. If I add these two, it's X plus X equals 88. 2X equals 88. Divide. And boom. FEG or DEF are both equal to 44. So take a minute now and get that down. Taking a look at number 2. Here we know FED is 27. We're still bisected, so we know these are the same. Find GED. Well, if this is 27, this is 27. So if I add the two, it'll give me the total. So 54 is our answer here for number 2. Take a minute now, get that down, and go ahead and draw your diagram for another problem. Labeling these diagrams is probably the most challenging part of any one of these angle problems. So make sure you take your time and draw neatly. So again, still bisecting, so we know these are the same. So we have DEF is 3x plus 1. DEG, so that's my whole thing here, is 5x plus 19. Well, we're finding x. Well, if this is 3x plus 1, this is 2. So 3x plus 1 combining subtracting our variable to the left here x is 17. You'll notice problems 4, 5, and 6 are very similar, and you could check your answers below. So at this point, you are completing problems 4, 5, and 6. You have completed those problems. Let's move on to number 5 for some more notes. Alright, so for this one we're going to work on problems 1, 2, and 3 together again, and then you'll finish the rest, and again you'll see that those answers are located at the bottom. Alright, so let's see. D is perpendicular bisector of AC. So, perpendicular means I get some right angles here, and bisector means that AB is the same as BC. So that's what those hash marks mean on there, that they're congruent. So let's see. If AC, so I'm going to leave that red on there because I know that those things are always going to be true. And then also, if these are right angles, these are right angles. So I'm going to do my work for each one here in blue, and again, kind of erase each time. So you want to make sure you're redrawing this picture for each problem. Okay, so AC, so I know from here to here is 17. I'm going to find AB. Well, bisects means that this is X, this is also X. So here, X plus X equals 17. So as a decimal, we would get 8.5. It'll take a minute. Go ahead and finish getting that down before I erase. So number 2, we already kind of said this, but DBC, so DBC, this gets the idea that these angles, if one's right, they're both right. If one's right, both. One, both. So DBC would just be 90 degrees, or you could put a right angle. Here, if ABE is 6x, so number 3 now, ABE, so this angle, 6x. Find x. Well, we know it's a right angle, so that would mean 6x is equal to 90. Dividing. There's a decimal here, we would get a nice whole number, x is just 15. So at this point, you are finishing a lot of practice problems. So, what you're working through is numbers 4, 5, and 6 on this page. Then, we're going to 6. Here, we're going to work through everything. On 7, we're working through everything. And 8, oh, I just showed you 8, so 8 you're doing everything. 7's here. So again, you'll notice you got some answers here at the bottom. So make sure we're checking our work there as well. Moving on now for notes 9. So at this point, you should be pretty much all the way done through 8. Now we're going to take a look at 9. Alright, so for 9 here, we're going to finish a good chunk of these problems together, and then we're going to work through some on our own. So a transversal is a line that intersects 2 or more lines. So in our diagram here, the one that's intersecting 2 lines here would be T. So T is a transversal with lines L and M. Okay, we get a lot of angles formed by these things. So, corresponding angles. Angles on the same side of the transversal and in the same position. Well, let's go look at our transversal. So we said, same pictures above, T is my transversal. So if I want to find some lines here, corresponding. Okay, they're on the same side of the transversal. So they're either both on the right or both on the left. And in the same position. So if I look at the top of this part and the top of this, 2 and 6 are corresponding. You'll notice they also look the same. So, not trying to trick you guys, if they're corresponding, they are equal to one another. So let's go ahead and say 2 is equal to 6. Another one here would be 3 and 7. Going on our left side here, well, 1 would go with 5, so 1 is definitely equal to 5. And then 4 and 8. Alright, alternate interior. Interior angles, non-adjacent, opposite. Okay, so let's see. Interior means I'm between these two lines. So this would be an interior. Alternate, so the opposite side, and interior. Here, 4 and 6, so 4 is equal to 6. Those are also going to be congruent. Going with the other ones here, we'd have angle 3 congruent with angle 5. So 3 and 5 also the same. Technically, the symbol for congruence is written like this, but to keep things simple, if you write equals, that's also totally fine with it. Let's highlight that transversal again. Alternate exterior. So exterior means I'm outside those nice lines there. So we're looking at, let's say 1. We'll alternate again. Let's jump the line. 1 and 7. Exterior, alternate. 2 and 8. This is definitely something like a note card thing for a test, just to make sure you guys have that down pat. Consecutive interior. These ones are kind of a special case. So consecutive and interior mean they're on the same side and right next to each other. These ones aren't going to be equal, but what I can tell you is that if I add them together, let's think. Well, in a lot of cases they're going to be equal to 180, but in general, we just want to think that they can add together. So consecutive interior, let's just write that out nice. 3 and 6, and on this side, 4 and 5. We'll get into later on when those things equal certain numbers. Okay, so we're going to do one of these together, and then you will work through the next one here. So we'll do number 1. You guys work on number 2 for homework. Okay, so we have an option no relationship, but let's see what we can do. 1 and 8. So our transversal here is the line that's going through both. Actually, you know what? To keep it simple for you guys, this one's crazy complicated looking. Let's just not do 2. But what I do want you to do is complete number 1 on your own as homework. So use those pictures above in your notes to complete this problem. So your homework would be to finish 9. And then, we're going to go ahead on to 10. So this one a little more complicated, but I think you guys can figure this one out. So here, use the color coordination specified, or just write out the words or the names. Your choice. Once you finish that, we're moving on to 11. Alright, so looking at our notes here for number 11, we're going to go ahead and just do problems 1 and 2 together. And then you guys are going to work on a few on your own. In fact, let's again simplify a bit here. We'll get rid of 3 and 4. And 5. And 6. So we'll do 1 together, and you do 2 on your own. Alright, so a little bit of vocab here. Reviewing from earlier, corresponding or congruent. Alternate exterior, alternate exterior congruent. The one thing I hinted at in the last set of notes, consecutive interior, if it's parallel lines, then they're supplementary. So that means they would add to 180. So here, we have parallel lines. So that's what these arrows here mean. So this means that this line, if I called it L and M, because they have those double arrows there, that means that they're parallel. So L parallel to M. So that symbol there means parallel. Okay, so here's what we know. We know that angle 1 is 65 degrees. So let's go ahead and say here, this is 65 degrees. We're going to find everything else. And we're even going to throw in some justification. Let's think about angle 2. Okay, well 2, they're linear. It's a linear pair. So, it's a linear pair. That means they should add to 180. So if I did 180 minus 65, that would give me 115 degrees. So angle 2 is 115. Now, I'm going to show you how to do this using just that angle 65. There's a lot of ways you can go around this. You can use the idea of a linear parallel line. But let's use a different one. So angle 3, well, that's vertical with angle 1. So that's vertical angles. And those are the same, they're congruent. So that means angle 3 is also 65 degrees. Angle 4, let's use that vertical trick again. Well, 2 and 4 are vertical. There were two lines intersect. So that's another vertical. So that means this one's 115. Now, I'm going to use a couple tricks here. So let's look at angle 5. Well, angle 5 and angle 1 are those corresponding angles. Same side, same position. So since it's corresponding to angle 1, it's the same as angle 1. Now let's check out 6. Well, one way to look at these is their same side interior with 3. So same side interior, and we have parallel lines. So these two need to add up to 180. So let's do 180 minus 65, 115. Angle 7. Let's look at these two. Let's look at angle 7, angle 1. Those are on opposite sides of our transversal here. So if we call our transversal T, they're on opposite sides of T, and they're both exterior. So that means they're congruent. So alternate, exterior. They're congruent, well, so that's just the same. And if we use that same idea here, let's go with linear pair again. So 5 and 8 are on a line. So, linear pair. So that means 5 plus 8 has to equal 180. So here, we'll find again 8 is going to be that 115. So, using similar logic, go ahead and complete example 2 now as homework. Once you've done that, what I also want you guys to do is to go on 12. Here, we're going to go ahead and work through 1 through 8, and again, you'll see you can check your answers at the bottom. Alright, moving on to our last section of notes for this unit. We are on number 13, and we're going to do numbers 1 through 8 together. Alright, so key idea here, we got L is parallel to M, and we got ourselves a transversal. So first thing I'm going to do is highlight every transversal in these. Whether you want to mark it as a T or just draw it in a little thicker when you write it out, it helps out. We also know that all these lines are parallel, so that adds some fun to the mix, because we get to use all those wonderful rules we just kind of covered. Alright, so, looking at the angles I know things about. Same side, and there's one on outside, one inside. Those are corresponding. So they're equal, they're congruent. So I know 58 is equal to 5x minus 2. Dividing. X is equal to 12. Number 2, they're on opposite sides, so there's something with alternate, and they're outside those parallel lines, so it's alternate exterior. Also equal to each other. Here we get x equals. Okay, so this is saying this angle here is 25. 125, and this is 7x minus 1. Well, we're on alternate or opposite sides, so it's alternate something. And these are interior of those parallel lines, so it's alternate interior. Also equal. You'll notice the big commonality here of setting these things equal. Here we get x is 18. Okay, so we know they're parallel. So I'm looking at this angle and this one. Well, they're on the same side. And they're interior. Well, I know about those. With parallel lines, that means they have to add to 180. Combining our like terms, remember, same side of the line, just combine. X is equal to. Here, let's see, we're on alternate sides, and opposite sides, it's alternate. And they're outside, so it's alternate exterior, which means they're equal. So moving my variable to the left. Now, you'll notice I'm going kind of fast through these. If you want more examples of solving equations, feel free to look back at those Unit 2 notes. That'll kind of work you through, again, the step-by-step logic here if it's going a little too quick. Number 6, on the same side, one in, one out, so those are corresponding. And also still equal. Always move that variable to the left. Here we get x is 9. Moving it down. Alternate sides. We'll actually do number 9 together too, by the way. And they're interior, so they're equal. You get x equals 2. This one, same side interior. That means they add to 180. Same side of the line, just combine. End up with x is 15. Alright, now you'll notice a lot of these ones. We got more than one variable. So we're going to solve for both. So let's do 9 and 10 together. So that kind of minimizes your guys' practice to just a few problems. Okay. Hints on these. We're always going to solve the things with same variable, the x's first. So looking at my x's, well, they're alternate sides of that transversal. Here's our transversal for this one. And here's our transversal here. So alternate sides in both interior. That means they're equal. So let's start off with finding what our x is. So I know x is equal to 17. Now, before we can find y, I'm going to go ahead and plug that in here. So if I plug in 17, that would give me 6 times 17 plus 3, which is 105. Now if I look at these angles, which I'm going to go ahead and highlight in blue, or actually it's highlighted in yellow, so here and here, well those are same side interior, so I'm going to do that work in blue. Those need to add 180, so 5y is 35, plus, we said this angle is 105, it must be equal to 180. Same side of the line, so this is my line through the equal sign, I'm just going to combine them. We'll end up with y is equal. So 2 answers, 1 question. Alright, here, same thing. Solve your x's first. Those should add to 180. Plug it in. These, what are they going to add to? That's right, 180. Or you could think of these two being equal. So since these are alternate exterior, you could either set these two equal, or these two would add to 180. Let's go through and talk through these. My x's add up to 180, they're same side interior. These two add to 180, or corresponding, they're equal. So again, I'm highlighting all these transversals for us. Once those are corresponding, so they're equal. Well, these two should add to 180, so find the x, plug in, these two add to 180. X's, they add to 180. These are vertical, these should be equal. Okay, so now we got a whole bunch of parallels. So let's make it a bit easier. We'll skip 16 and 15. But I want you guys to try and figure this one out. So here our x's will be equal to each other, and these two should add to 180. Once you guys have finished 13, you are moving on to 14 for some practice. So you can color in at the bottom if you'd like. You know what, don't worry so much about the coloring. We're going to shorten this up a bit too. Let's get rid of 11 and 12 and 9 and 10. So here we're just going to work on numbers 1 through 8. Once you've done that, you're working on your review. When you're done with it all, your last mission is to pass that Unit 3A test.